in performance, there's two parts. Number one, finding the problem, and once you find the problem, you fix the problem. Well, if you write in the code, you better not find any problem, but oftentimes you'll be asked to do performance tuning on other people's programs. So let's look at the tracing part, where you find out where the problem is. In this example, we picked our most complicated program so far, the select statement program. So if you go to utilities, more utilities, runtime analysis, it gives you two options, SE30 and SAT. Well, we actually have a better one. We don't want any of these. There's a new one called ST12. Okay, so it's got two modes. One is the user task mode, one is the current mode. In the user task mode, put your user ID and you say if it's a background or a dialogue, and then from then and then you start trace. If you do that, from then on, anything, any click you do, anything you do, whatever, even if you're using this transaction itself, it'll be recorded. It's getting traced. So they recommend using two user IDs. One is to manage this one, but filter it using the other user ID, so that the other user ID is doing work on this, so that doesn't get traced as a username. Anyway, let's do the current mode. In current mode, you run a program as if you're running from SE38. So sometimes you have to run background trace background processes, then use user tasks, things that are running in the background. Anyway, we execute the trace, put we're not doing the variant, because then it'll getting the variant itself is an operation, and that gets traced too. So your trace becomes dirty. So your trace is over. So you go back and see, I just recorded a trace. So it's two things. One is ABAP trace and performance trace. ABAP trace tells you, okay, so first of all, on the top, you'll see how much ABAP, the statements you wrote in ABAP, how much time that took, as opposed to how much time did the data selections you did in the database took. So remember, you have application server and the database server, they're separate. So how much time did the application server take? How much time the Oracle database server take? So right now here, we're only looking at the ABAP trace, so only the whatever the application server ABAP code ran. You'll see that there are stuff here that you never wrote. That's because our code is so simple, it took so little time. These are actually, remember the selection screen came and some stuff that happened that we didn't code for. Selection screen is a, as you remember, is you write 2-3 statements, select options, and then SAP creates the screen for you. So all these classes are called for those things. Also, when you typed New York, some pop-up came. Those are these, okay? Let's look at a familiar statement. If you look around, you'll probably find it. But the only important thing is here, there's 2 times here. Number is how many times this particular statement is getting executed. Again, this is not your code. Your code is somewhere. Gross time, how much time it take in total. But what is net time? Well, this loop, whatever loop it is, took 30,000 microseconds to run, but the loop statement itself took only 53 microseconds. Inside the loop, it's calling other statements. So gross is the gross statement is the time taken by loop and whatever happening inside the loop. Net is just the statement itself. That's the only important thing in here. Then let's look at the SQL trace. Okay, that's important. Here, first we get this one. So all the so now object name. Object name will tell you the table. So in our code, if you remember, in simple select, we did 2 selects on our own transfer table. One select star into corresponding, one is actually specified. So let's see how they performed. I double click. So this is the one, and I click here. Not here, not here. Let's reduce this. It's too big. See this. So if you click this one, you'll see that this is the SQL statement. This is just to illustrate the point that this is the raw SQL that executes in the Oracle side. Here you see the MANDT is specified as 220. We don't have MANDT here. So the MANDT is specified here because the whole separation of client independent is a SAP thing. SAP adds this thing and sends it to Oracle. Anyway, to tell you which statement took how long, how many records were selected, etc., etc. I have 2 because one took about 1300 milliseconds more than the other. Let's see. Go back. Oh, this is the original. Remember, ST12 is combination of 2 old transactions, SAP, ABAP Trace and SQL Trace. So go to summary, go to table name. So this is a summary of this table. Okay. So it happened twice. One took 2000 and took only 498. So here, this is this. Remember we put select star into corresponding fields? Well, SAP's optimizer converted the star into first name and last name anyway, because they are equivalent. So when you look at here, there's only one. There's no star here because Oracle doesn't understand star into corresponding fields. ABAP optimizer converted, but since we did the conversion, it took 1300 milliseconds, microseconds more. That's like 1 millisecond more. That's why it's okay to use select star. So in the same way, you can look at this is the SPFI. Yeah, we have so it took. Wait, now that we know which ABAP statement, the ABAP trace, which ABAP statement is taking more time, and which SQL statement is taking more time, we can do fixes. What kind of fixes can we do? Well, most dangerous I've seen in my experience, the most time, if you go to ABAP Trace, if you look at here, this is the general scenario. The ABAP code takes the longest, not the database select. That's because people have become very smart in doing the database code. They know how to write efficient select statements, but ABAP coding still work needs to be done. So most big problem is the loops. Anything you do in a loop, loops can run for thousands and millions of times. So if you write select statement in loops, you're doing something wrong. Absolutely try to avoid it. I mean, sometimes you cannot, but try to avoid it. We spoke about for all entries. Instead of doing select in a loop, you can do a for all entries. Function call performs in loops. Well, inside every function call, there might be a select statement. So you're essentially doing select statement in loops. So see if you can avoid that. Maybe if it's instead of using the function module, you look at the code and do the select and do for all entries. If that makes things complicated, but sometimes you have to do it. Read table statement is another culprit. Use sorted table and do binary search, or the best policy is to use internal table index. Works only on later versions of SAP. Mass operations on internal tables. Suppose you want to copy one internal table to another. You can always do loop on an internal table and then copy the work areas to each other, then append. But instead of that, see if you can do copy, or you can append also. Append lines of one internal table to the other. That will work only if the tables have similar structure. You can look for help on that. Maybe you can create the tables in a clever way, make them, tables are actually different, but you made them similar. When you made two tables need to be appended. They're not same structure, so not same type of table. You cannot append them, but in the designing itself, you do it in such a way that they have similar structure. You put more stuff than needed, more fields than needed. They'll be empty, but at least they'll be similar. Then you can use these clever things. Field symbols, we showed field symbols, saves a little bit of time, very minor. Suppose you're using performs in a loop. There's something called static variables. So in static variables, we check if the value between perform calls, the static variables retain their values. So you can always check if last perform call the value was same, so why try to extract the value again? For example, you're doing a select based on material number in a perform. In the last perform call, the material number was same. So since the material number is same, the select statement result will be same. So why do the select statement again if the material number remains the same? Also, some clever coding will help when you actually sort it by material number, remove the redundant ones. Sleep, wait, those things are dangerous. Also, synchronous RFC calls. Synchronous calls and asynchronous calls. There's asynchronous. That means in synchronous, remember how we used to submit your old yahoo.com, Yahoo Mail page and wait for everything to load? And now in Gmail, this is all asynchronous. You load your Gmail page once, the chat, someone logs out of chat, someone comes into chat or hangout, this all happens asynchronously. The page remains on your browser, but all this new information keeps coming in the background. So a synchronous call is like that, and you call another program, you submit it in the background, and your program keeps running, and the other program call happens in the background. Whenever the other program finishes executing, you display the result. You get the result instead of waiting for it to finish. So this is how you fix the ABAP coding problems. Now, database, as you saw, the second problem, of course, there's only two parts of the problem, ABAP and database. System you cannot avoid. System is system. It's the latency of the system. So database, use indexes in database tables. You can define indexes in SE11, we know. But if you only tracing ST12, you can see if the indexes are being used in your select statement. For that, you have to, in the where statement, the order of the fields should be exactly same as index. Or at least use as many fields of the index as possible. Sometimes you have to define secondary indexes, and oh, the index for my particular select, there's no index defined, and then, yeah, I have to make it fast. Then you discuss with the basis and create secondary indexes. But as you know, that creates, if you create indexes, there's an overhead and insertion becomes slower. Select and select loops. Select actually the database optimizer will make it optimized, but then avoid it anyway. Select star, as you saw, is actually only 1 millisecond penalty. So people will tell you it's slow, don't use it, but actually it's the same. Okay, and then inner joins are, as you know, is intersection. Reduces the data. And you join the tables, you actually select less data. So you have to design your program that uses maximum inner joins. Views, as we know, are two tables joined together in the data dictionary itself. So that's more efficient. If you're using two table joins repeatedly, instead of defining, suppose table A and table B are joined once. The second statement, table A, B, and C are joined, but you saw that A and B are joined twice in this case, right? A, B, first A join B, and second statement, A, B, and C. So instead of doing the joins twice, you define a view on the database table. It's a view of between combining A and B, and then you use the view and use the view here. No, sorry, it should be in the views. And then the last, not the least, is suppose you want to find the maximum of flight numbers. Instead of selecting all flight numbers and then looping through and then find the maximum, you can actually things like max on the select statement itself. So the load goes to the database server and not on your ABAP server to do these things. So push all your load into the database server. That's the key. And you can use the get runtime command. It's a statement in ABAP. You can define the performance tracing and some principles here and these things. Just read it. I don't know what exactly.